Alright, let's look at numbers. Alright, now you get many different types of numbers. Let's start off with natural numbers. Alright, natural numbers are basically your typical numbers, 1, 2, 3, 4, etc. Alright, now we get something called integers. Alright, integers are numbers that range between negative numbers and positive numbers. Right. And 0, of course. Alright, negative, positive, and 0. Alright, then you get something called prime numbers. Alright, prime numbers are basically numbers that are divisible by 1, right, and itself. Okay. What does that mean? Let's look at some examples. There's 2, 3, 5, 7, 11, 13, 17, etc. Alright, there's many. If you look at the number 2, it can only divide by 1 or itself without leaving a remainder. Right, let's look at the number 7. 7 can only divide by 1 or itself without leaving a remainder. And same applies for the rest of the numbers. Right, now you get something called square numbers. Right, these are basically numbers that are the result of a number multiplying by itself. Right, let's say 1 times 1 equal to 1. This is a square number, right? 2 times 2, 4. 3 times 3, 9. This is a square number. This is a square number. Alright, it's a result of two numbers that are the same multiplied by themselves. Alright, then you get something called cube numbers. Cube numbers are the same, except it's the same number multiplied 3 times by itself. Right? So 1 times 1 times 1 is equal to 1. This is your cube number. 2 times 2 times 2, 8, 8. That's your cube number. 3 times 3 times 3, 27. That's your cube number. Right? You can also write it as 1 cubed, or 2 cubed, 3 cubed. These are basically equal to each other. Alright, now you get something called multiples. Right, multiples are basically numbers that are divisible by the given number. Right, divisible by the given number. Right, let's look at an example. Right, let's take the number 9. The multiples of 9 would be all the numbers after 9 that can divide without leaving any remainder. Right, so 9, 18, 27, 36, 45, and etc. Alright, let's look at another example. Let's say the number 15. Right, the multiples of 15 would be 15, 30, 45, 60, and etc. Alright, within multiples you get something called lowest common multiple. Right, the lowest common multiple, let's look at an example so that I can explain this much easily. All right, let's take these two. Oops. Copy, paste. All right, now to find the lowest common multiple of 9 and 15, right? LCM, or you can also say this as LCM, right? LCM of 9 and 15. Right, what you do is you go along the multiples of 9 and you go along the multiples of 15. Right, now you find a number that's common to both. Right, so if I go along 9 and 15, I would notice that 45 is common to both. There are going to be more numbers that are probably common, but this is the lowest common multiple. Right, so the lowest common multiple of 9 and 15 is 45. Right, Now let's look at something called factors, right? Factors, this is basically a whole number that divides into a number exactly, right? Let me just write that down. Whole number that divides into it exactly. What do I mean when I say this? Let's say the factors of 12, right? These are numbers that will go into 12 without leaving a remainder, right? Let's say 1, right? 2, 3, 4, 6, and 12. All these numbers basically will go into 12 without leaving a remainder, right? Let's take another example, 36, right? And they're all less than the number. So like 12 would be the highest factor of 12, right? Of 36, you get 1, 2, 3, 4, 6, 9, 12, 18, and 36, right? Those are the factors of 36. Now, within factors, you get something called the highest common factor. All right. It can also be referred to as the HCF. Okay. Um, let me just take these two as an example. Copy, paste. Righty. Now, when we go across 12 and 36, we have to find a number that's common to both, but it's the highest number. So 1 and 1 is common to both, 2 is common to both, 3, 4, 6 common to both. When we come to 12, 12 is common to both and it's the highest number that's common to both, right? So the HCF of 12 and 36 is 12, right? Now let's look at prime factors, right? So you get factors, now we're looking at prime factors. It's in the name. Prime factors are factors that are also prime numbers. Factors that are also prime factors. Prime numbers, sorry. They're also prime numbers. Alright, let's say the number 48. Right. The prime factors of 48, you write down all the factors of 48, and all the prime numbers within those factors would be your prime factors. In this case, it would be 2 and 3. Because they're both prime numbers and the factors of 48. Right. Now let's look at something called product of prime factors. And to explain this, let me use an example. Right. Let's look at an example. Let's say the number 54. Alright. To find the product of prime factors of 54, you would want to divide 54 by two numbers, right? That when they're multiplied, they will give you 54, right? Let's say the number 2 and 27. If you multiply the two of them, you would get 54. Now, 2 is a prime number, so it can't be divided further. 27 can be divided further into, say, 3 and 9, because 3 times 9 is 27. 3 is a prime factor. 9 can be divided further into 3 and 3. So if you notice, these are also prime factors. They can't be divided any further. So to write this as the product of prime factors of 54, I would say 2 times 3 times 3 times 3. Right? And to simplify this, I would say 2 times 3 cubed, because it's 3 threes. And that's your answer. Let's look at another example. Let's say the number 120, right? 120 can be split into two numbers. Let's say 10 and 12, because 10 times 12 is 120. 10 can be divided further right, into 5 and 2. Now, if you notice 5 is a prime number, it can't be divided down any further. 2 is a prime number, it can't be divided down any further, right? So we divide 12. 12 can be divided into 2 and 6, right? 2 is a prime number. 6 can be divided into 3 and 2. 3 is a prime number and 2 is a prime number, right? So to write the product of prime factors for 120, I would say 2 times 5 times 2 times 3 times 2, right? So the three twos, I'd say 2 times 2 times 2 times 1 3 times 1 5. All right, and to simplify this, I would say 2 cubed times 3 times 5, and that is your answer. Now let's look at something called rational numbers. All right, basically a rational number is any number that can be written in the form, right, in the form a over b, all right, where a and b are integers, all right, and b cannot equal 0 because you can't divide by 0. Okay, so they have to be integers. Oops, they have to be integers, and they can't divide by 0, and b can't be equal to 0. Right? Some examples of rational numbers are, let's say, a half, 3, 4 over 2, 3.5, 4, 4.6, and many others. Right? Now you get something called irrational numbers. Irrational numbers, to put it simply, are basically numbers, right, that are not rational. Not rational. Examples of this can be pi, fourth root of 12, cube root of 4, numbers like that, and etc. Okay, now you get something called reciprocals. All right, a reciprocal is basically a pair of numbers, right? Pair of numbers that when multiplied, they will give you 1, right? Let's say the number 12. The reciprocal of 12 would be 1 over 12. Why? Because 12 times 1 over 12 is equal to 1. And that happens for many other numbers out there.